So a good introduction to geometry is dimensions. So let's start with the fewest amount of dimensions. And when we talk about dimensions, we're talking about spatial dimensions. So the fewest amount of spatial dimensions that we can have are 0 dimensions. So what would something look like that has 0 dimensions? It would be a point, just like that. Now, when I actually wrote that point, this little dot on this board, this actual dot that I wrote does have dimensions, because if you were to blow it up, you would actually see that it would be kind of like a tiny circle. That is not what I'm actually talking about. I'm talking about it's theoretically a singularity, meaning like a black hole all comes down and crunches down to one infinitesimally small point. And that small point beyond imagination has no dimensions to it. It doesn't even have the dimensions of a tiny, tiny circle. It just has no dimensions, no up, down, left, right, no depth to it, no dimensions. So this point is representing something that has no dimensions, when in actuality, the ink on this board actually does have a little bit of spread to it. Okay, so that's what is a dot, a point, a singularity is no dimension. All right, let's move up from that. So let's have one dimension. So you can have one dimension, which is a line, okay? So a line has one dimension because it either goes to the left and right, or it goes up and down, or it goes diagonally. But this is a dimension. It's just one, and it's just distance. So one dimension is distance, okay? So if we were to run a race, we would be running in a direction. And if we ran 5 miles, then we would say we have a distance of 5 miles. So 5 miles, miles would be the units, and that is describing how much left or right motion we have gone. So miles, inches, centimeters, any kind of distance, millimeters, metric or empirical system you want to measure in, it would just be a distance, a one-directional distance. So that's one dimension, a line, or a line segment, which sort of stops and ends but doesn't go on forever, or a line that goes on forever. Those are all one-dimensional. So 0 dimensions would be a point, and 1 dimension would be some sort of line. Okay, let's move to 2 dimensions. So if you have 2 dimensions, what you have is 1 dimension going this way and another dimension going some other way. It doesn't have to be like at a 90-degree angle. You know, you could have 2 dimensions like that if you wanted. The idea is that we are not dealing with just one distance, but 2 distances. So this board is a flat surface, and I understand that, yes, there is some depth to it because there's maybe like a 1/4 of an inch of depth to it. And yes, even the pen that I wrote and inked this board with has some depth to it, because if you zoomed in, the droplets of ink would actually have some depth to it. We're just doing theoretically though. Okay, so theoretically, we're gonna say this is a 2-dimensional surface. So we have an up, down, that's one kind of dimension, and then a left, right, that's another dimension. Again, we're talking about spatial dimensions. So when we have something that's 2-dimensional, it has 2 lengths to it, and you can measure those 2 lengths. So when we are measuring a 2-dimensional surface, what we can do is incorporate this new notion of not just distance, but area. So a two-dimensional shape will have an area, meaning all of the coverage that's inside and bounded by that shape. That's what area is. The amount of coverage or surface that is bounded within that 2-dimensional shape. That's what area is. So length is just measured in distance, like inches, like this could be 8 inches this way, and I don't know, maybe like 9 inches tall. But then the area is actually going to be in units that are square units. So while we talk about inches in terms of distance, when we're looking at the area of a two-dimensional object, you don't use distance, you use something called square units. And it's called square units because it's literally units in the shape of little squares. Okay, so let me show you what that looks like. So let's say that I'm going to use a rectangle, not because I couldn't use any other kind of shape, two-dimensional shape, but because this is a good way just to start off with. So let's say that I'm going to break this rectangle up into 1, 2, 3, 4, 5, 6, 7 units that way. So 7, we'll call it 7 inches, all right? But it could be any kind of unit. And then each of these distance markers is 1 inch, okay? Or we're saying that just for these purposes. So then I'm gonna go 1 inch this way, and then I'm gonna go like this. You see how I go not just horizontally, but vertically now? So this is the horizontal axis, so to speak, and then this is the vertical axis, you could think. So this vertical direction, I'm gonna take this 1 inch, or this 1 unit, let's call it an inch, and then I'm going to whoop, go like that, okay? So if I go like this and here, I'm gonna mark it off like that. So this is now 1 unit horizontally and 1 unit vertically. We'll call it 1 inch horizontally, 1 inch vertically. And so that makes a little square. A square is a rectangle where all of the sides are the exact same length. So we're gonna pretend that I drew this perfectly and that the horizontal and vertical distances are exactly the same. So it's got 4 sides to it, and each of those 4 sides are exactly 1 inch, or 1 unit in this case, okay? So I'm gonna do that across the entire row here, okay? Across the entire row as best as I can. And then I'm going to literally inch up the whole way. So I'll do another inch here, and then another inch right here, okay? So obviously, since I am freehanding it, these are not perfect, okay? But we are going to pretend that all of the little shapes inside this big rectangle are gonna be perfect squares. I know that they don't look like perfect squares, but because it's 1 inch this way and 1 inch this way, 1 inch this way and this way, 1 inch this way, 1 inch this way, theoretically, we're gonna call everything inside this rectangle little tiny squares, smaller squares. Okay, so how many inches vertically is this rectangle? 1, 2, 3, 4. So this is 4 inches of vertical distance. So again, we have horizontal distance, which is 1-dimensional. We have vertical distance, which is also 1-dimensional. And when we incorporate that into a shape that has a distance this way and that way, we call it a 2-dimensional shape, or a 2D shape. D for spatial dimension. Okay, so now we're up to a 2-dimensional shape. And this 2-dimensional shape has area to it. And the way that we measure area is in square units. Now, how many square units are there here? We could count them up. So we could add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, and 28. I counted 28 square units. So the area of this rectangle is 28 square units. So we'll write that square units. In this case, we're calling inches. So square inches. Inch by inch, inch by inch, okay? So this right here, I'm coloring in 1 square inch, all right? And if I were to color in 28 of those, I would fill out the entire area of this particular rectangle, okay? So that's why the area of this rectangle is 28 square inches. When we talk about square inches, we literally mean squares. So that is why area is in units that are squared, because they are literally small squares that make up the entire 2D shape. Like literally squares. So it's not just a phrase that we use because it sounds nice. It's because it's literally little tiny squares. Okay, so I also want to give a little bit of notation. Instead of saying square inches, there is another way that we can write it. You can obviously write it like this if you like, but just so you have some notation, sometimes you'll see a little two above the inches. This is called a superscript. Script means to write, super means above. So this superscript 2 means squared. It's a superscript that in this case is also an exponent. So this 2 you could call an exponent. There's lots of names for it. You can say a power, even degree, but we're just going to call it squared. If a 2 is an exponent or a power or a degree that's in the upper right-hand corner and it's little tiny, it's called an exponent. And if it's a 2, we call it squared. By the way, if this was a 3, we would call it cubed. If it was 4, we would call it to the 4th power, so on and so forth. Okay, so just so you know, instead of saying square inches, you can also say square inches and it would look like this. So you don't have to write out this whole word square. All right? Here's another very important thing that I see students do a lot. If they come up with the area of, say, this rectangle, what they're sometimes improperly doing, they want to say 28 square inches. And so what they'll do is 28 squared. And they'll say, that's my answer, 28 square units. And this is not representing 28 square units. This is representing 28 squared. 28 squared, I don't know what that is, but it's a pretty big number. It's less than 900, but not a lot less than 900. Remember, there's 28 squares here. There aren't 900 squares here. There's only 28 squares here. 28 to the 2nd power in math means the equivalent of 28 times 28, which equals, again, something that's in the hundreds. We do not want to multiply 28 times 28. We just want 128. There's 28 squares and no more in this rectangle. So we don't want to square the 28. This is squaring the value, the numerical quantity. The quantity, meaning the number of squares in here. We don't want to square the number of squares. No. This number of squares is 28. So let's not square that. I see this a lot, so please do not square the actual quantity. You can use the little 2, the exponent, but when you do so, make sure that it's your units that you are squaring. So 28, that's the value. That, don't touch that. But you can say inches squared. So 28 inches squared, or 28 square inches. This is how you would write that notation. Please do not put the 2 there. That means something totally different, okay? So just because we're using inches, I have inches squared. But this could be for anything. It could be centimeters squared. Oh, and sometimes we don't write out centimeters. Sometimes we just use the abbreviation, which is fine too. So for inches, you could write IN with a little 2 at the top. That's great. If it was centimeters, you could do CM. So this would be 28 square centimeters, or 28 centimeters squared. Do you see this 2 is acting upon this unit, but it's not acting upon the quantity of the units. So this is totally fine. If these were centimeters, then so be it. Then this entire rectangle would be 28 square centimeters, 7 centimeters this way, 4 centimeters that way, and you have now square centimeters. Totally fine. Okay, so that's how we come up with the area of a 2D shape. And in the next video, we're going to move on to 3D shapes, which have depth to them as well. Right now, we're just on a flat surface, but we are going to represent in the next video an actual object like this that you can hold. Thanks.